Let's begin. Today is August 18th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's all-odd lineup of criteria cards are 3, 7, 9, 17, and 21, and the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by going to turingmachine.info and searching the code. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at our middle digit, our square digit, and compares it to the number 3. So should the value of square be less than 3, equal to 3, or greater than 3? Criteria card B looks at our last digit, the circle digit, and the Turing machine will let us know whether its value is an even digit or an odd digit. Criteria card C will look at the 3-digit solution and will let us know how many of those digits are 3. Should there be no 3s, a single 3, perhaps 2, maybe even all 3 are 3. Criteria card D again looks at our 3-digit solution, but this time will let us know the quantity of evens in the solution. Are there no evens? Is there 1 even? Perhaps 2? Maybe all 3 are even. And finally, criteria card E again looks at our 3-digit solution, but this time will let us know a little bit about its structure, so to speak. So the solution could either have a pair, as in the example 131, or alternatively, no pairs. And there are a couple scenarios. One where all the digits are different, as in the example 134, or all digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all 5 criteria cards. And we're going to start off with an initial proposal of 314. So the first thing I want to do is I want to test criteria card B. I want to know a little bit about that last digit. Okay, so in this case, the Turing machine does not approve of my choice. Notice that I did choose an even 4. The Turing machine does not approve of that. So let's go ahead and type that up in section B. And that is that circle is an odd digit. And since it is odd, I can go ahead and cross out all of the evens. So I can cross out 2 and 4. The next thing I want to test is whether there's a pair or not. So let's go ahead and test criteria card E. Okay, so in this case, the Turing machine does not approve of my proposal. Notice that I do have all distinct digits, and that's an example of no pairs, but the Turing machine does not approve of it. So it's basically letting me know that yes, there is a pair. So let's go ahead and type that up in our notes for section E. So that the solution has a pair. Okay, and since it does have a pair, notice that we already have this one odd. It could be that there's another odd among triangle and square that will be paired up. But it's also interesting to note, criteria card D. Obviously, we know that there can't be all even since we do have an odd. So it could go from 0 to 1 to 2. And notice that I also have 1 even in my proposal. So let's go ahead and test that out. So that is criteria card D. Okay, so it does not approve of the fact that I only have a single even. So what that's telling me is that either there are no evens or perhaps there are 2 evens. So let's go ahead and type that up in our notes for section D. That the solution has, let's see, we'll say no or two evens. And again, the reason that is we know that there can't be three since we already have a single odd. It failed on just having a single, so either there are no evens or two evens. Well, that does it for this round. We've already completed our 3 Turing tests. Now we're moving on to the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, letting us know a little bit about the value of square, and also we did not test the number of threes. Now the other interesting thing to note is there really is no mention of triangle. So typically in these situations, somehow triangle will be forced into a particular value, and it could be something like, something having to do with square or triangle, or maybe even the fact that maybe there are 2 evens and square is one of them. So it could be that we're dealing with 2 evens in triangle and square. Square will let us know which of the even there is, and triangle will have to mimic it. And then perhaps the fact that we have criteria card C, and maybe that circle will be 3. So let's go ahead and so I'm thinking it's either going to be 2, 2, 3 or 4, 4, 3. And so let's go with 4, 4, 3. Let's see where that takes us. Okay, so I'm thinking that we're going to probably have to test criteria card D again just to verify that we have 2 evens. But yeah, let's go ahead and test criteria card A. Okay, so fantastic. So we did, I guess, at least confirm that square has to be greater than 3. So let's go ahead and type that up in our notes, that square has to be greater than 3. And so what that means is that square cannot be a 1, cannot be a 2, and cannot be a 3. And again, I feel pretty confident, but I think I'm going to have to test criteria card D again and confirm that we do have 2 evens. So let's go ahead and test D. Yes, okay, fantastic. So that was criteria card D, and so we'll just cross out here. The solution has 2 evens. So let's get rid of the no or. So the solution has 2 evens, and because we know circle is odd, we now can confirm that yes, square is 4, and we'll likewise cross out everything else for triangle since it has to mimic what square is. And I think we can deduce that there has to be a 3, because if it weren't a 3, then how would we pick between 1 and 5? I don't see anything that speaks of ordering or any other clue to help us decide between 1 and 5. So I'm going to actually write in my notes for C that I'm going to deduce there is a single 3. Because again, I cannot see a way to distinguish between 1 and 5. So when that occurs, that typically means that I call those ambiguous solutions, because you cannot distinguish between them. So yeah, so our solution looks to be 4, 4, 3. Okay, and let's go confirm. And so we concluded that 443 is our solution. So let's type that up. 443. Fantastic. Now let's actually see how we did versus the Turing machine. And notice that even though I did do tested criteria card D twice, I was able to deduce that C had to be a 3, and so we still did our 5 questions with our 5 criteria cards. So that's always a good indication that we probably beat the Turing machine. So notice that in the first round we did B, D, E and they were all wrong, and then we did A, D and they were both correct. So let's type that up. So B, D, E were incorrect. And then A and D were correct. And let's see how we did. Okay, so we beat it by 1 question. So I really do go back and again, notice that in the first round, we got all X's. So that should not be necessarily a stumbling block. We can learn from things that didn't work out, as long as you don't commit the same mistake twice. We did learn something from that, and we made the observation that, hey, there's no mention of triangle, so somehow it's being forced into a particular value. And good deductions that we perhaps had 2 evens, and of course we deduced that there was a 3 without having to test criteria card C. So overall, a very good puzzle. So please do add your thoughts to the comments. Give it a thumbs up if you liked it, and of course hit subscribe so that you don't miss out on the next video. Well, until next time, have a great one.